everyone. In this video, we'll describe the concepts of thermoregulation. And thermoregulation is basically a homeostatic process that keeps body temperature within acceptable limits. Normal body temperature is about 98.6 degrees Fahrenheit or about 37 degrees Celsius. And even though those are the numbers that we typically quote, there's actually an acceptable range that temperature could fall within. So it would not be unusual for a person to be, for example, 98.2 degrees Fahrenheit or 98.8 degrees Fahrenheit. When we consider thermoregulation, we have to consider the idea of a thermal gradient. So same as we've described a pressure gradient or a concentration gradient or an electrical gradient in the past, a thermal gradient basically is the difference between ambient temperature and body temperature. And we know that the ambient temperature could be higher or lower than body temperature depending on the weather. And that also tells us the direction of the gradient. So heat transfer will always be heat flow from high to low temperature. Therefore, if the body temperature is lower than the temperature outside, then the body will gain heat from the environment. And conversely, if the body temperature is higher than the temperature outside, the body will lose heat to the environment. And on a day-to-day basis, the body is managing all of the input and all of the output of heat in order to regulate the body temperature. So there are a couple of important mechanisms of thermogenesis or heat production, and they include work-induced such as exercise, diet-induced such as the normal metabolism that would exist from consuming and utilizing food sources, shivering, and non-shivering thermogenesis is basically utilization of hormones in order to generate heat. So release of things like epinephrine, glucagon, and thyroid hormone, which all can increase metabolic activity and therefore increase heat. And then the principles of thermolysis or heat loss include conduction, which is basically direct transfer of heat through physical contact, and heat travels from high to low. Convection, which is basically loss of heat to the air that overlies the heat source, and typically this occurs by utilizing air currents that pass over the body. Radiation is loss of heat in the form of infrared rays or radiation. Evaporation is changing state of matter of water from liquid to vapor. The change of phase from liquid to vapor actually causes absorption of energy, and as a result, the surface is cooled. Evaporation can be divided into sensible perspiration such as sweating. So sensible essentially referring to the idea that you notice that it's happening, and insensible perspiration, which would be, for example, coming from the lungs. And with that brings us to respiration, which is not always included, but when it is, it's sort of thought of as more of a subdivision of evaporation. So the maintenance and regulation of body temperature occurs through negative feedback. And when we review negative feedback, we think about receptor, control center, and effector. So our receptors are actually thermal receptors or temperature receptors. And there are central receptors, which lie deep in tissues, and peripheral receptors, which lie in the skin and mucous membranes. And as it turns out, there are actually many more cold receptors than there are heat receptors. The receptors generate action potentials and feed their information to the control center, which is the hypothalamus. And the hypothalamus functions as the thermostat of the body. And the output is left to the effectors. And basically, the hypothalamus has a heat loss center and a heat gain center. And the heat loss center is controlled by the parasympathetic division of the ANS. And the heat gain center is controlled by the sympathetic division of the ANS. And so we can just talk briefly about the events that occur when there is a disruption in the baseline body temperature. So if we have an increase in body temperature above the set point, so approximately 98.6 degrees, we activate the heat loss center in the hypothalamus, and we have a parasympathetic response. So the actions include vasodilation, which allows for heat loss through radiation and convection, sweating, which allows for heat loss through evaporation, and increase in respiratory rate, which allows for loss of heat from the lungs through evaporation and respiration. They're sort of interchangeable in this situation. Now, of course, like all negative feedback mechanisms, the actions are turned off when the body temperature returns to normal. And conversely, if we had a decrease in temperature below the set point, we would activate the heat gain center in the hypothalamus. And the actions of the heat gain center include vasoconstriction and shunting, bringing the blood towards the core with less exposure to the environment because it's further from the extremities. Shivering thermogenesis, which is basically involuntary skeletal muscle contractions that will produce heat. And non-shivering thermogenesis, which we mentioned, is responsible for release of certain hormones in order to increase metabolic activity. So the ultimate goal is to control fluctuations in body temperature based on the rate of heat production and heat loss to the environment. And we know that maintenance of homeostasis in this department is critical because if we have a significant increase in body temperature, we know that we can have similar effects as if we had a decrease in pH, including protein denaturation. And conversely, if we had a significant decrease in body temperature, we would have a decrease in metabolic activity and slowing of many important functions. Although short, that concludes our discussion of thermoregulation. Hope you enjoyed it. Thanks for watching.